When you're looking down from a satellite, you learn something about what's in the water, and pollution is one of the things that could be in the water that we might want to measure.
Yes, what you measure is actually how the surface waves are dampened. So you see the tiny little ripples that are on the surface, oil and also biogenic slicks, plant from algae when there's a big bloom.
So that's a natural...
That's a natural slick, and they also dampen water. So you need to distinguish between natural slicks and slicks that we have created, humans have created. But now there are algorithms for doing that. Their spatial signature, the way they look on the surface is different. And also the natural slicks gets washed down very quickly. So with high winds they disappear, but oil stays put a bit much longer before it's blended in.
So the idea is that the actual chemistry that makes up the slick stays close to the surface of the water, and that changes the way that waves travel across the water. And it's that very subtle bit of information that you can use to infer that the slick is there.
It suppresses the ripples, and what the satellite sees is actually the ripples, and we call it surface roughness. And if you have lots of ripples, then the satellite image is much brighter, but where the ripples are suppressed, it will be dark. So the oil slick will appear dark, and the clean water will appear brighter.
So there's two different types of thing you're talking about detecting here. There's oil slicks and then there's algal blooms.
Yeah, the algal blooms you don't, unless they're actually on the surface, you can't see them in radar images. So you use ocean color satellite, and they will see the chlorophyll pigment in phytoplankton. And where you have lots of phytoplankton cells, you have high chlorophyll. And where you have an algal bloom, where the plankton have really ideal conditions and they grow really fast, you get very high chlorophyll concentrations. And some of those blooms are known as harmful algal blooms. It's in the name. They can be harmful.
They're toxic to us?
Yes, some of them are, not all of them. Some of them are simply harmful because to marine animals and to fish, and so they're dangerous, for example, for aquaculture, because they take all the oxygen out of the water when they die, or they can smother the gills of fish and lobsters and things like that, or just put a blanket of dead stuff on the sea floor and smother things. And then when they decompose, they take all the oxygen out of the water, so animals suffocate. But the ones that are really dangerous to us are the ones that are toxic. And some are so toxic that you can actually get poisoned by just being near them, on the dockside, for example.
So they're very famous because this red tides are something that wash in on some beaches.
Not all red tides are toxic, and the satellites can't tell you whether the bloom is toxic or not. What they can tell you, you know that the toxic ones are likely to occur when it's nice and warm and under certain conditions. So you have a good idea that this bloom might be toxic. But the only way to check that, absolutely, is to send somebody out to take a sample. But the toxic blooms are dangerous even if they're not so toxic. You can get poisoned by being near them. They are the most insidious one is where they poison shellfish. The shellfish are happy because they're used to eating these, ingesting these algae. But if we eat the shellfish, we get very ill. And because fish can also they tend to react to the same toxins, so you can kill fish, but not necessarily bivalves, mussels and things, oysters and things like that.
So the satellites can help us build a warning system that says there's potentially a big algal bloom, but then something still has to go and check about whether it's harmful or not.
And that is done with ocean color satellites. Now where you really benefit and get a double benefit is because in the last 5-10 years we have started using ocean color satellites to detect oil spills as well. And that means that, for example, in places where you have relatively cloud-free skies most of the time, and you are not so dependent on having a radar satellite, which are very expensive and the data isn't always available, and usually you have to pay for it. The ocean color data is usually free, so a lot of countries, for example, in the subtropics, will run semi-operational oil spill services, which also monitor for algal bloom, doing all with the same satellite, slightly different processing, but same satellite, and they get a double warning system, so their warning goes to different people perhaps. One is to clear up the oil pollution and catch the culprit, but the other one is a general warning to aquaculture industry, to fishermen, to anybody who's eating bivalves. Don't do that now.
So tell me about the dual use of the oil spills and the ocean colour for measuring pollution?
Yes, because in ocean colour satellites we have discovered can also be used for oil spill detection. They weren't so much used initially because Europe is Northern Europe in particular, is quite a cloudy place, and that needs radar satellites. But they've started experimenting with using ocean colour satellites. So as long as it's cloud free, you can use them for oil spill detection. And in the MERIS and MODIS, because their resolution is good enough for that. And in the Middle East and in subtropics generally, there are places where they now run a semi-operational service where they look both for oil spills and for harmful algal blooms from ocean colour data. And the processing for the two is slightly different, but you can run the same service from the same satellite with more or less the same people and just two different processing chains. So you save a lot by doing it that way.
And if you're looking at an oil spill, you're not just interested in where it is now, but also in where it might go to.
Yes.
And satellite data is useful for that as well.
Yes, I mean the two things you use satellite data for in oil spills. One is to give you an overview of what the spill is like. The two types of satellite you use for oil spill detection and overview is synthetic aperture radar, SAR, and ocean colour satellites, MERIS and MODIS. Well, not MERIS anymore, obviously, but Sentinel-3 will be doing the same thing. And the overview is really important because it tells people where the oil is now. And with that, you can also verify the models that you use to predict where the oil is going to go in the future. So the satellite images that detect the oil can be used to check if the models are correct. And to run the models for prediction, you need environmental data in near real time, and that comes from satellites. So you get wind data from scatterometers, you can also get that from synthetic aperture radar. You get wave data from altimeters, and you get where the ocean currents go. And surface oil is slightly different from just things in the water column because the wind is the biggest thing that influences where the oil is going. It's being pushed by the wind. But as the oil goes along, it'll be mixed into the water at the leading edge, so it goes down into the water. And as soon as it gets down into the water, it's the ocean currents that matter. And unless you have a model that takes account of the wind pushing the oil and the oil being mixed in and being pushed along by the currents, which don't necessarily go in the same direction as it goes to an angle of the wind, then you might go really wrong saying where the oil is going, but the models are much better now. But they need the satellite data in order to run properly.
And you couldn't have, the whole point of an oil spill, I guess, is that you don't know where it's going to go, so you need something that's got very large spatial coverage to cover all the places it might go.
Well, you need to know where it is, and then you need to run the models to see where is it likely to go. And that needs environmental data, which you can get from satellites, and then you have a good model. And then you check as you go along with the new satellite data that you got it right and adjust things if you haven't got it right. But the overview is really good for another thing, important thing as well, because not so much from radar data, you can see there is oil, but from optical satellite data, you can actually get an idea of how thick that oil is. And oil spill thickness is really important for the spill response because it tells you where to concentrate your efforts for protection, where is there most oil. If you want to do things like controlled burning, or if you want to scoop it up and mop it up, or use booms to collect it together and then suck it up and take it away, all of that won't work if it's just a really thin layer of oil. So you need to concentrate your efforts where you've got the thick oil, and the satellites can tell you where that thick oil is.
So there's a lot of subtlety in oil pollution itself, in how thick the oil is, how far it can spread, maybe what type of oil it is and how that interacts with the local parameters. So having this sort of synoptic view, or a bigger scale view, that's so useful. If you didn't have that, it would just disappear off to sea and you wouldn't know where it had gone.
Yeah. No, and that is one of the I don't know if you've heard of the disaster charter. It's all the satellite agency providers have an agreement. It's started by the European Space Agency, but everybody has signed up to it now from all over the world. And if there is a disaster anywhere, all the satellites that are in orbit over that area will collect data as they're over there. And when you had the big oil spill in the Gulf of Mexico, NASA collected their own data, but they also invoked the disaster charter. So all the commercial providers, European Space Agencies, Chinese satellites, anybody who went over that area could collect data. And they set up a crisis center, and that crisis center consists of experts who know what data is going to be most useful, how to process the data to give the information they need, and then they feed that to the cleanup operation and the people actually managing the oil spill on the ground.
So even though the satellites are still going around on the same orbits, they can actually change the focus of what they're doing,
Yeah,
where they're
they do.
feeding data to respond to an emergency.
Yes, they may not normally be switched on over that particular area, because things like radar, for example, they will not always take images because they need a lot of power to run the radar, and so they're often switched off just to preserve power. But they will turn on over that area whenever they pass over. And some of the commercial optical providers may not normally collect data except over land, but they will turn on over the ocean if they know that there's a spill to look out for.
So it's an impressive coordination.
It is. And you need this coordination center which can order the data and direct the satellite data providers, and also pass the information on, because it's a very specialist thing.
It's potentially extremely powerful having so many different types of satellites. Just look at one patch. That's an astonishing thing.
Yeah. Yes, no, it is. And I mean, for oil, the ones that actually detect the oil and tell you about the oil itself, that's the optical and the synthetic aperture radar. But all the others are going there collecting environmental data anyway, and that is being assimilated into the models that tell you where the oil is going.